Hi, in this video I'm going to show you how to use the Excel solver to solve a linear programming problem such as you might find in Chapter 4 of your MyMathLab homework. If you take a look at what's on the screen, I have homework from section 4.2 open currently, and I'm looking at a maximization problem that says to maximize this z function, the objective function, subject to these constraints. Okay, I'm going to put this in the Excel solver, so I'll need to open up Excel. But before I do that, I'm going to use the snipping tool on the desktop to copy the problem. Okay, now what I'll do is I'll minimize the homework so we can see Excel. And here's my Excel spreadsheet. In order to be able to run the Excel solver, you have to be able to activate the add-in first. Okay, on Excel, the way you do this is you go up here to File, and you click on that, and then you go to Options, then Add-ins, scroll on down so you can see Excel add-ins, and click on that and say Go. And then what you want to do is you want to make sure the Solver add-in box is clicked. I also am putting in the Analysis Tool pack since that is useful for running some statistical tests. So let's click OK. And then when I go up to the Data tab on my Excel spreadsheet, you'll see that the Solver and the Data Analysis Tool pack are available now. Okay, so what I'm going to do first is hopefully paste the problem that I copied from homework over here. Okay, so now we can see it. And what I'm going to do is I'm going to set aside 2 cells in the spreadsheet for decision variables. So my actual data will be in column A, and I'm going to use column B for labels. So over here I'm going to say these are my decision variables. Okay, so I'm not going to put anything in cell A1 and A2, but the Excel solver will populate those. I'm going to go down a few rows, and then I'm going to put my objective function here. Now this is my label. The function itself is going to be a formula in cell A4. And let me see if I can move this so you can see the row numbers. Okay, so I'm going to put the right-hand side of my Z function here. So I'm going to start with equals, and then you can see it's 9 times the first decision variable plus 4 times the second decision variable. So let me type that in as an Excel formula. 9 times the first decision variable, and I'm clicking on cell A1 since that's where that decision variable's value will be, plus 4 times A2. There's the second decision variable. You can see Excel is nice enough to highlight the cells that I'm pulling into the formula so I know that they're correct. When you're done, tab off the cell. Don't hit enter because that's liable to put some garbage in the cell you don't want. You can see I have 1, 2 constraints and then the typical non-negative constraints. So I'm going to go down a few rows and say constraints. And then I'm going to put in the left-hand side of each of the constraints. Okay, so remember they have to be formulas, so they start with equals 3 times the first decision variable plus 2 times the second decision variable, tab off the cell. Don't worry about the right-hand side of the inequality. We'll fill that in with the solver. Okay, here's the second constraint, which is equals the first decision variable plus 5 times the second decision variable. And then tab off that cell. Okay? Now we're ready to bring up the solver dialog box where we can fill in the right-hand side of these inequalities and set things up to run the solver. So I'm going to go to my Data tab, which is where I am right now, and click on Solver. You can see this dialog box comes up. All right. Now it says Set Objective. This needs to point to the cell with your objective function rule in it, and it's pointing to the wrong thing. So what I'm going to do is highlight that and then click on the cell that has my objective function A4. I want to maximize the objective, so I'm going to leave this radio button clicked. By changing variable cells, this means by changing the decision variables. So what I'm going to do is go over to A1, click and drag to hold down to A2. That's going to put a range in the variable cells box. So my decision variables are in A1 and A2. Now let's go down to the constraint box, and we're going to add the two constraints one at a time. So once I'm in this box, I'm going to click Add, and a little constraint menu comes up. And it's asking for a cell reference first, so I'm going to click on the first constraint, which is in A6. You can see over here that the constraint in A6 does have a less than or equal to. There's a choice. It defaults to less than or equal to. And now I'm going to type in the right-hand side, which is 10. And that matches this inequality. Okay, I have another one to add, so I'm going to say Add. And then I need to put in the second constraint, which is in cell A7. It's a less than or equal to, and the right-hand side of it is 9. Once you're done with all your constraints, click OK. You get one more chance to look at the solver parameters dialog to make sure your objective is in the right place, you're set to optimize the way you want, your decision variables are correctly set, and these are your constraints. The last thing to do, by the way, notice unconstrained variables are non-negative. These are your non-negative constraints that say x1 and x2 need to be greater than or equal to 0. The last thing we want to do is set the solving method. So we're going to go down here and click Simplex Linear Programming. Once that's done, all that's left to do is click Solve. And you can see that we have some variable values in here. So this is saying that x1 is 3 1/3 and x2 is 0, and our objective is maximized at 30. This also tells you the value that your constraint variables achieved. Okay, the first constraint, whatever it meant, was maximized, was dealt with at 10, and the second constraint didn't make it all the way up to 9, it was only 3 1/3. So what I'm going to try to do is go back to my MATLAB and type in 3 1/3 and 0 for my decision variables and 30 for my objective function. So let's see if I can move the viewer window and get back to that. Okay, I'm going to say keep the solver solution, minimize this, and bring up, my homework. Okay, so I'm going to say the maximum is 30 when x1 is 3 1/3, so 3 and use a fraction, 1/3, and x2 is 0. And let's check that. You can see I got it right. So this is how you're going to use the Excel solver to do the maximization and minimization problems in your MyMathLab homework. As always, if you have questions, please let me know.